That's like 6
All right. Can I bring your attention up here, please?
I guess.
Okay. So we are going to do what's called trigonometric substitution. So instead of u substitution, where we let u equal something, we are actually going to set x equal to some sort of trig function. X equals cosine theta. X equals 5 sine theta. Something like that. Okay? And we're going to do that based on our knowledge of trig identities. Okay? And the 3 versions of the trig identities that we're going to be focusing on would be cosine squared equals 1 minus sine squared. I think that is like ingrained in your brain already anyway, right? But then, as we forgot yesterday, secant squared is 1 plus tangent squared, and then we can rearrange that. So what's going to happen is we are going to have some integrals that involve potentially one of these radicals, or, I mean, sometimes we might have like u squared minus a squared to the 3 halves power. Okay, so it doesn't necessarily have to be straight up radical. It could be a fractional power, as long as the root is 2. Okay. Yes. Okay. And we're going to, you are really good at u substitution, and you understand how it works. Trig substitution is a little bit different in the process we have to take, but if you know how to do u substitution, then we can apply kind of those concepts of substituting in and replacing with what we're going to do here in trig substitution. Okay? Now, I don't think that we have to write everything down on this next slide, so don't get overwhelmed. I'm going to talk through some things, okay? I'll tell you what I think you should write down. Okay.
Sounds very good.
Okay. So, just relax. And let Miss Holman plug in so I can actually advance the slide. Okay.
No. I just
Okay, so just look at it right now. If we have a square root of a squared minus u squared, okay, and u could be like an x, maybe it's like a 4x, okay, we don't really know, okay. Let me just watch me for a second, and then I'll give you an opportunity to write down what I want you to write down, okay. If we let u equal a sine theta, then watch what happens. Okay? We would get the square root of a squared minus a squared sine squared. And what would we be able to do? We would be able to factor out an a squared. And then what is the equivalent of 1 minus sine squared? Okay, so we would have a squared cosine squared. And then what happens? Poof. We have no more radical. I meant to do that. A cosine theta.
working perfectly.
Okay, I know it was really nice. Okay. So what I want you to write down is this right here. If we have a square root of a squared minus u squared, we're going to use this substitution. Okay? And even if you don't remember this, you can at least play around with what to plug in knowing your identities. Okay? Now, when we get to the end of this integral, it could involve sines, cosines, tangents, some sort of trigonometric function. So let's say we get to the end and my answer is 3 theta plus secant of theta. Okay, I don't know. Okay. We're using trigonometric substitution, which means we can draw a triangle that represents that substitution. Okay? So here is theta. The sine ratio would be u over a, based on this, right? And the Pythagorean theorem would let us put this. Oh, strange. There's a relationship there. Okay? And then if I had secant of theta in my integral, I could represent that with hypotenuse over adjacent. Okay? We would know how to substitute back into whatever we were using. Okay? If you have the square root of a squared plus u squared, we can let u equal a tangent theta, and then we set up our nice trigonometric identity with the 1 plus tangent squared underneath the radical. Based on the 3 identities I had on the on the first slide, what's going to be our third type of trig substitution?
U squared minus a squared.
With the secant.
You can't deny it.
You're not,
It's not denying it. What?
I'm throwing like.
What?
Yeah, it's
Yeah, it's just an honest question. Honest response.
So when you do these integrals, it is important that you let me know your substitution. Okay? If you're going to let x equal 4 secant theta, then you would have to determine dx. Okay? If you're going to substitute x, you're also going to need to substitute dx so that everything's in terms of the same variable. Okay? You also need to draw a triangle that represents your substitution so that when you get to your answer, we can change back into the original variable. If I give you an integral in terms of x, your answer better be in terms of x. Okay? So the first problem we're going to do, you know the answer to without having to do trig substitution. But I thought maybe we could start with a very simple example to just get our brains wrapped around the idea, and we know what answer we need to get to. Okay? You're looking at me like maybe you don't know the answer.
Is it
We
arc
got
sine?
this. I mean, no.
This is arctan.
Say it.
Arc sine.
Arc sine of
4 over x. Or x over 4.
x over 4. We should get arc sine or inverse sine of x over 4 plus c. We all know that.
No, not
It's the thing in memorized
It was the antiderivative I told you to write down on
It's
Thursday.
the sine over
Thursday? Tuesday? Wednesday?
What was the date?
It was.
I don't know. I'm sorry.
I'm there.
Okay.
It was October 8th.
Yeah, I don't read it.
Yeah, that day. All right. So, since we have a squared minus u squared,
I see
So forget if it's
a sine theta. So 4 sine theta.
x is going to be replaced with 4 sine theta. which means a couple things. Here's our right triangle with an angle of theta. Just pick an angle to be theta. What is our sine ratio? Our sine ratio is x over 4, right?
Yeah.
Sine of theta equals x divided by 4.
Sure does.
Which means our Pythagorean theorem is the square root of hypotenuse squared minus leg squared. Okay. Now, if we're going to replace x with sine 4 sine theta, I can't have a theta with a dx. So we also need to replace dx. So dx would be, well, what's this derivative? 4 cosine theta d theta. You're going to have to do your differentials. So now we can make our substitution. So this is actually the integral. Well, we're going to make it the integral of 1 over the square root of 16 minus x squared. Well, what would x squared be? Can I write it as 16 sine squared theta right now? Is that okay? And then dx gets replaced with 4 cosine theta d theta. So we replace all of the x's and we replace dx. So your integral looks like it is more complicated for a moment. Okay.
Oh, I see.
Okay. So yeah, some of us have division. Okay, that's okay. What can we do in our radical? Factor out of 16. And this is going to happen every time. And what is 1 minus sine squared? Okay. So we have the square root of 4 cosine squared theta in our denominator. I'm thinking ahead, just like some of you are, but I'm trying to be very diligent about all of my steps. Just for you, Caleb. I'm looking.
That was Anthony.
So our denominator becomes 4 cosine of theta.
What? It shouldn't equal 1.
Or should it?
How is that the same thing as
Just-
sine?
Can you just take a deep breath?
So it's okay.
Isn't that equal theta?
Should, it's okay.
So we have the integral of 1 d theta. Yes. Which means our antiderivative is?
Theta plus.
Okay. But what did I tell you? Is that the answer that I want?
Yes.
No! We started out with an integral involving x.
Oh,
What's theta then?
I'm very far.
That's why we draw our triangle.
Oh.
Please.
Whoa.
Okay.
I get what you're
There's
saying.
one of two things we can do here.
X is equal to 4 sine.
So sometimes you need your triangle. Can I go back to the top now?
Yeah.
Sometimes we need this. So this is the same thing as x over 4 equals sine of theta.
Yep.
So theta is the same thing as,
Or sine of x over. But how do you know that you're supposed to use x over 4 and not like?
You just
You have
solve.
3 sides.
Solve.
So how do you know not to do like arc? Like to say cosine of theta equals radical 16 minus x squared over 4.
okay, so
And it's
technically
arc
you could choose
cosine.
any of them, but what I would do is if you have a theta in your answer, I would go back up to your substitution and solve that one.
But theoretically, if
Theoretically,
you just happen to,
you-
forget that,
You could technically choose any of them from your triangle to do.
so I would
Yes.
still get it right if I had like arc cosine
So our answer
radical 16 minus x squared over 4.
Yes.
is.
But the answer that I would appreciate would be the inverse sine or arc sine of x over 4 plus c. Okay?
Oh
Well, that was a simple one.
Oh.
No.
Uh-oh.
I'm just being honest with you. Now, do you feel that maybe the more we do this, we could maybe look at this and be like, oh, that's going to be 4 cosine theta? Like, do you think we'd be able to do that without
Perhaps.
Is it going to be 1 every time?
1 1?
Like, is it
One
going to be the
big
same
theta.
thing on top and bottom? It goes to 1.
No. Remember, I told you I picked
It's 1.
an easy one that we knew the answer to, right?
Okay.
Let's do one more like maybe what you'd see in your homework, maybe on a test or quiz.
Ooh, this looks spicy.
Picante.
Conte.
I disagree, but
You don't think it looks spicy?
I don't think I'm up with it in terms.
I don't even know how to
Does
explain
Quentin ever,
spicy
like-
slang term.
Make you question yourself because he just like says buttery a lot and stuff like that.
I feel like everyone just defines
Because I went in your class, I think it was last year. Is he in your class this year too?
It seemed like interesting.
I do
but
not have
also
to
like
do this year.
somewhat impressive, but
Because I went in
also
the
like
class
just a
one
bunch
time.
of
Okay.
stuff.
In order to use trig substitution with an identity that would be helpful, what substitution should we make?
The 2c theta.
Okay, we have the x squared, I'll say x squared minus 2 squared. So x can be 2 secant of theta.
Oh my god.
I'm already not there.
Okay,
It's because it's on the top instead.
What is
doesn't matter. It's because it's x squared minus 4 instead of, so in our previous example we had 16 minus x squared.
that was
And-
this arc sine.
That's when we used sine to substitute. But when you have the x squared minus the number squared, that's when we have to use the secant to substitute so that we can use the 1 minus secant squared for our, or excuse me, secant squared minus 1 for our identity.
Okay, I got. I'm there.
Okay. So our secant ratio is x over 2. And our side would be the square root of hypotenuse squared minus side squared. Okay, and we can't substitute x equals 2 secant theta without substituting dx also. What's the derivative of 2 secant theta? Ah. Okay, so there are the substitutions. So x squared becomes 4 secant squared theta minus 4. X is 2 secant theta. And dx is 2 secant theta tangent theta d theta. You see why I would love to do this in the first
This is
to be able to like,
I gotta say,
and then I don't have to keep scrolling up and down.
worked out pretty nicely.
It will work out pretty nicely. Okay. Okay. Help me out with how much work you want me to show.
Everything.
No, just a
Every minute detail.
Can I go ahead and cancel out 2 and 2?
Yes.
Yeah.
Can I go ahead and cancel out secant and secant?
Oh,
Yes.
Oh man, that's
I
nice.
like that.
Okay. So we have the integral of the square root. We know we're going to need to factor out this 4.
Oh. So then it's tangent squared.
Okay, so this is tangent squared right here.
Yeah.
Okay, so I have the square root of 4 tangent squared.
So
So
it's
do
2
2 tangent. So 2 tangent squared theta. We're there.
We'll let you see
We have.
And we're done. Like,
We still haven't even integrated. We're not done.
Move the 2 out.
Okay, so yesterday you were annoyed. Why are we talking about trig integrals? Well, that's so you can do trig substitution. Okay, your intervals. Maybe you weren't annoyed, but your integrals are all going to involve trigonometry, to where we need the strategies from yesterday. Okay.
Okay.
Can I integrate tangent squared?
no.
Yes, we did that already, didn't we?
No.
No.
That, like,
No, you cannot.
Let's split it
No,
up
you can't.
into cosines
Okay.
and sines.
I trust you.
Ow.
You guys me on my homework every time.
Formula.
How?
Couldn't you do a lot of confusing power ratio formula?
And Nick and Benjamin.
Oh. Are you having fun yet?
I heard about Kayla's test.
Oh wait, we changed it.
Why did I do that?
I don't know.
Do we know the
Because-
antiderivative of secant squared?
We sure do.
Oh.
We sure do.
Oh yeah, clever. Very.
What is that antiderivative? You all said yes.
Tangent.
And what's the antiderivative of 2 times 1?
Well, would you put the 2 theta there or would you just put
I
theta?
would put 2 theta.
X.
It depends on where if you put parentheses or not. So I went ahead and decided to just distribute the 2.
Yep.
If you'd like to put the parentheses to just have theta, that's also fine.
So now we have to do the theta.
Because like C is like a random number that you're plugging in. And theta is a expression that you're plugging
Theta
in.
is
You need the 2.
I'm
this.
gonna do the theta thing.
okay. So we get to do a couple things here. First of all, this answer is in terms of theta. Boo, our original integral is in terms of x, so we got to get back to x. Okay? Tangent of theta. Here's theta. What is the tangent of theta? Opposite over
Yep.
adjacent.
There.
So the tangent of theta is radical x squared minus 4 over 2.
It is.
Well, if it's only
Times
2,
2.
you can just get rid of the
Yes.
Couldn't you
2.
just
There.
go back to the equation, put in arc secant of x over 2? Wouldn't
Don't do that.
you don't want that?
No.
But it
Do
would
that.
work.
I don't want that.
Okay.
Especially if I give you something where you have to plug values into it, right?
Ooh.
Yeah. All right.
So now we're done.
So if you have some sort of trig function like we did here, go to the triangle and give me the ratio. Okay? That's like geometry.
Like, something X on 2.
Theta, well, we know that x over 2 is the secant of theta. So theta would be the inverse secant of x over 2. Yes, if you wanted to cancel out those 2's, go for it. But I'm not going to make a big deal about simplifying. But maybe I should.
You
No, that's even more hands-off on the test.
I'm gonna get that more than I'm gonna get anything else. I don't like those cubes.
God.
Questions before we do our last example? Okay. Then let's do our last example.
Right down. Somebody looking like that for this. Or
What?
something.
Ooh,
Three
something
lines.
strange.
No.
Oh, this
there's
is the-
another sign.
Oh, never
Oh
mind.
no.
What is that?
Okay, Zane.
No, no.
Okay.
Yeah.
If we had 1 over 4x squared plus 9, you would be excited.
Oh, okay.
But we have a radical and we have that pesky x.
Yeah.
Okay? Now this one looks different than the first two because we have 4x squared plus 9. So if we think about this in terms of the Pythagorean theorem, this is 2x the quantity squared plus 3 squared. Do you agree?
Yes.
So in order to make our substitution, we are going to let 2x equal 3 tangent theta. U equals a tangent theta. 2x equals 3 tangent theta.
So the x in the front doesn't matter. You still do the same, like.
It's just whatever is under the radical
Okay.
or the root. Okay.
So are you gonna substitute for x 3 tangent theta over 2 then?
So I'm going to substitute for x, yes, 3 halves tangent theta. And I'm going to substitute for dx, 3 halves secant squared theta d theta. Okay. Now, our tangent ratio would be 2x over 3. And so I'm going to label my triangle accordingly. Sorry, Richard. Please forgive me.
God, you don't have to go low
It's a little.
I have
angle
theta. It's good
thing.
enough.
Alright.
Okay. Are we all okay with what we have here so far?
Yes.
Okay. So we have the integral of 1 over x, which is 3 halves tangent theta, times the square root 2x squared would be 9 tangent squared theta. Are you okay with that? 2x squared.
Uh-huh. Oh, it's 3 times 3. Okay.
Mm-hmm.
9, 2. Okay, she just like moved the square.
And then dx is 3 halves secant squared theta d theta. Well, hey, 3 halves can cancel. Yeah, that's it. So we have secant squared theta over tangent theta. What happens with our radical? We can factor out the 9, right? What is tangent squared plus 1?
Secant squared.
So this becomes 3 secant of theta. Can we do that?
Yep.
Okay.
Oh, okay. Yeah. Cool.
So I'm going to bring the 3 in the denominator out front so we don't have to worry about it.
Okay.
And we end up with secant theta over tangent.
Yeah. Oh,
That's secant over cotangent? No.
Oh, this is very cool.
Now what?
This is what happens.
Now we got the.
Secant is 1 over cosine.
Yeah.
Divided by tangent is sine
Yes.
over cosine.
Cool.
So we just have the integral of
Very nice. I like that.
oh crap.
I don't like
Now
that.
what?
What is the antiderivative of cosecant? That's one you have to look up.
So we don't have to
Can't
know
do
the
it?
test.
It's negative the natural log of cosecant theta plus cotangent theta.
How do you know it?
Whoa.
Because I looked it up.
How you get to it?
For another day.
Blindly following.
Okay? If you get the integral of secant or cosecant, it's not like one of our normal rules. Okay, so don't panic.
Look it up.
Look it up in your book. Then, in order to get back to x's, come back to your triangle. What's the cosecant ratio?
Wait a minute.
Hypotenuse over opposite.
Of course, you looked up the formula. It's negative.
Plus our cotangent ratio. Adjacent over opposite.
I think they were probably not.
At least there's like a very minimal amount of problems on the homework.
Like 20 feet.
There's, yeah, it's like 15 questions.
I don't have my gold sheet in front of me.
There's 2 for each section. Yeah.
How many are bolded?
2 from each section.
It's only 2.
Ah, pick 2 from each section. So there's like 3 different sections of problems. So it's 5 through 16 broken up into 3 sections. And you need to pick 2 from each section to do. So you have 6 problems.
I can do that now.
Yeah.
Good thing we got over here. Bye Nick, bye Benjamin. Thanks for tuning in.
Don't forget to
Smash
smash
that
that
like
like
button.
and